Let's take a look at worksheet 5, number 5, the last one on that worksheet. Here we have Fritz Haber's process for making ammonia. Nitrogen plus 3 hydrogens give you 2 ammonias, and you have some data here to consider. First things first, as always, write your general rate law expression. The rate is equal to some lowercase constant k. First reactant is N2 to some order. Second reactant is H2 to some order, and we're going to solve for those orders. I look for a series of experiments where I change one thing and only one thing. And in a well-designed series of experiments, I would first alter the concentration of hydrogen. Then I would leave hydrogen alone, and I would alter the concentration of nitrogen. Well, I look at experiments 2 and 3, and I left hydrogen alone. Moving from 2 to 3, it looks like I went up by a factor of 4 with regard to nitrogen. And it certainly looks like I went up by a factor of 4 with regard to my rate. They didn't bother to tell me what I'm measuring, but 8 over 2 is 4, 200 over 50 is 4. I would say changing nitrogen gives me a one-to-one relationship. Nitrogen is first order. Okay, so now I need a series of experiments where I leave nitrogen alone and change only hydrogen. And that doesn't happen. So all is lost, right? No, it's salvageable. Let's see if we can figure out through a little logic what's going on here. The only thing I need to figure out is what is the effect of hydrogen. I know the effect of nitrogen, changing the concentration of nitrogen. So if I look at moving from experiment 2 to 1, there are 3 things I can say with certainty. I know that nitrogen went times 2. I know that hydrogen went times 2. And I know that my rate, 400 over 50, that went times 8. I also know that this is first order, which means if this was my only factor, the rate should double based on nitrogen alone. But it actually went times 8. But it would have been times 2 based on just nitrogen alone. This ratio here, 4. That's the effect of hydrogen. So hydrogen went times 2, taking into consideration the effect of nitrogen. The leftover factor is a factor of 4. Oh, that's second order. All was not lost after all. I was able to apply what my rate actually is divided by what my rate would be based on my known. And that gave me a factor of 4. Well, that's the effect of my unknown. So let's turn to worksheet 6, second page. We've got a fairly complex system here. A plus 2b plus 3c goes to 2y plus z, and they give you a fairly large table for your data. General expression for your rate law. Rate is equal to some rate law constant. I've got 3 reactants, A to some order, B to some order, C to some order, and we're going to set out trying to find the orders for A, B, and C. I look at experiments 1 and 2. A does not change, C does not change. Going this way, 0.03 over 0.02, that's by a factor of 1.5. I increased B by a factor of 1.5. Well, 15 over 10 is also a factor of 1.5. Pretty confident in saying B is first order. Okay, I'm going to look now at experiments 3 and 4. A is not a factor. B is not a factor. I doubled C, and my rate doubled. Oh, okay. C is also first order. I'm going to recopy the data. Okay, fresh data table. So I figured out the order of B, I figured out the order of C. Now I look for a series of experiments where I changed only the concentration of A. And it does not appear as though this is a very well-designed series of experiments. So I need something where I changed A. Let's see if I can find something that was held constant. Experiments 2 to 3, A changes, B changes, C changes. I don't want to do that. What about 1 to 3? A changes, B does not change, and C does. Well, I can work with that. Here I know that the concentration of B doesn't change. B is not being considered. That's good. So I really only need to consider A and C. So let's list out the factors we know. A doubled. C doubled. My rate increased by a factor of 8. C is first order. Based on C only, the rate should go times 2, but it actually went times 8. This ratio, that's the effect of changing A. Oh, A doubled. That's 4. Doubling A has a net effect of a 4-fold increase. A is second order. So I've got my rate law expression, K, A squared, B, C. So in question 4, that corresponds to choice D. Question 5 says, what about Z in experiment 3?